Hello again. This is day 5 from Unit 3 or Chapter 4 in the book. Um, Given what we've just done in the previous 4 days, we won't. We're mostly just going to do a review and do some mixed problems. So I'm just going to choose some problems. This is actually from the assignment, so I don't want to take all of the fun away from you and do all the problems. But I do review stuff. Sorry, I'm getting a pen ready. Okay, so I'll do numbers 3, 6, and 9. Multiples of 3. They're my fave. Notice this guy? There's no number out front. So I don't need to do like the whole, A times C thing. What I do, so I can go straight to, hey, I know that the two terms are going to start with an X out front. And with that, if the X is out front, then I just think of two numbers that multiply to be a negative 14 and add to be 5. So we can write that down. It's a negative 14 multiplied to be negative 14 and adds to be 5. There's only a few factors of 14 here, and they are negative. Well, we know one's going to be negative, one's going to be positive, so I can test it out. I know that 14 and 1 work. I know that 7 and 2 work, but they're going to add to be a positive 5, or rather, these are opposite signs, but when I add them together, it needs to be positive, so the larger number needs to be positive. So then this would be negative 1 and a negative 2. When I add them together, this would give me a 13, and this would give me 5. So those are my numbers. And then we plug them in. We found our numbers. So we factored it. These problems should be quick at some point. The last part is to set it equal to 0 and solve for each case. X plus 7 equals 0 and x minus 2 equals 0. X plus 7 equals 0. I'm going to subtract 7 both sides and add 2 to both sides on this one. So x equals negative 7 and x equals 2. Okay, so that example should be pretty basic at this point. Not this again. Number 6, we'll notice that we have a leading coefficient here. And so I'm going to actually do number 5 instead. It's a little bit better for our purposes. So what we notice in this one is we have an x to the third. That's kind of weird. We're used to seeing x squared. But I also noticed that each term has something in common. This is always the first thing that you should look for. It makes your problems, sometimes it's absolutely necessary, and other times it simply just makes your problem a lot easier. Either way, you should always do it first. They all have an x in common. So I can take out an x from everything. They also all are divisible by 2. So I take a 2 out, then I'm left with x squared. For the first term, I got the 2 out and one of the x's. And then for the next term, I got a 2 out, so it's a negative 2 and one of the x's, so it's just an x. And then the last term, I got a 2 out, so it's a 3 left over, and I took the only x it had out, so that's gone. Next, you have 2x, and then this trinomial can probably be factored, so we'll write our butt cheeks. They look like butt cheeks. And then we need two numbers that multiply to be negative 3 and add to be a negative 2. So there's only two numbers that multiply to be a negative 3, and it's 3 and 1. And if they add to be a negative 2, well, I know one of them's got to be negative because it's a negative multiplication, but if they add to be a negative 2, the larger of these two has to be negative. Okay, so negative 3 plus 1 is a negative 2. So this is minus 3 and plus 1. Now this example is a little bit, could look slightly different. When we set this equal to 0, the whole reason why we can split these things into cases is because we have this chunk right here times this chunk, and they're equal to 0. The only way that they could be equal to 0 is if one of the two of these, or both, were 0. So since we don't know which one is actually 0 that makes them multiply to end up getting 0, we have cases, and we say that this is x minus 3 equals 0, and x plus 1 equals 0. But notice this first term out here has an x in it, so we don't know if maybe this term is the term that's equal to 0. And maybe this is like 50 and this is 1,000, but this was the 0 term. Because we multiply them all together, you'd then get 0. Because this has an x in it, I do have to take it seriously, and it gets its own case. Maybe this thing was equal to 0. So we're actually going to get 3 answers for this one. And there's some reasoning behind this. Basically, there's fundamental theorem of algebra, or one of those. There is something interesting here in that what your highest degree is, what your highest exponent is in a polynomial, that's how many answers you should get. So this would be divide by 2 to both sides, and you get 0. Add 3 to both sides, you get 3. Subtract 1 to both sides, and you get -1. So in this problem, we got 3 answers because of that. And I just wanted to make sure we hit one of these that had a greatest common factor to start off with. Then next I'll do maybe number 7 or 8 or 7. So I notice it has a leading coefficient. I'm going to multiply a and c, and I get the multiplication of 12, and then it has to add to be a 7. So two numbers that multiply to be 12 and add to 7 is 12 and 1, just factors of 12, 6 and 2, 5 doesn't work, 4 and 3, and then if they add to be 7, we need to figure out which ones of these work. This is 13, this is 8, and this is 7. So those are my numbers. That tells me, and I'll do box method here, that tells me that my 7x is really a 4x and a 3x combined. So that's where we get our 4 terms. So for box, we have a 6x squared, a 4x, and a 3x, and a 2. And we're taking out, from both columns and both rows, a greatest common factor. This top one, they're only both divisible by a 2. This one, they both have an x in common, and then 3 is their largest divisor. Same thing here, 2, both divisible by 2 at the largest, and then 3x and 2 is a 1. And then so our 2 bubbles are 3x plus 2 and 2x plus 1, and that is equal to 0. So we split them up and we get 3x plus 2 equals 0, and 2x plus 1 equals 0. And then we want to solve these. We get -2, running out of room. So you get 3x equals -2, and you divide. And then -1, 2x equals -1. Divide by 2, x equals -1/2. All right, so that was box method. And I did one example of each of the 3 types of problems that you'll see. So hopefully that helps, and good luck.